In today's video, we're going to be looking at partial variations. So partial variations are relationships between two variables where our dependent variable varies partially with our independent variable. So to help you understand this definition, I'm just going to write out the equation for a partial variation. The equation is y equals mx plus b. And in this equation, we have y, our dependent variable, x, our independent variable, and we have these two variables here, m and b. And these two variables are constants, which means that no matter our value, regardless of our values for y and x, m and b will always remain the same. So if we like substitute values for m and b, we could have something like 4x plus 7. And that means m will always be 4 and b will always be 7, even if we just substitute x for 1 for x, and let's say, or another value for y. M will always be 4 and b will always be 7. Now, if you think back to the beginning of this video, I said that our dependent variable varies partially with our independent variable. And that basically means that if we multiply our independent variable by m and then add it to b, we'll always get y, our dependent variable. And it varies partially, not directly, unlike in a direct variation, because we always have to add this b. We can't say m equals y divided by x. It's now m equals y divided by x plus b. That's why it varies partially. So now we're going to be graphing an equation in the form of y equals mx plus b. And I just want to go over that m is our constant of variation, b is our constant number, but m is also a slope of a line. I mentioned this when we were going over direct variations in the last video. And it's the same concept here, but now we just added this b value, and b is our y-intercept. A y-intercept is basically where this line y equals mx plus b, an equation in this form, would intersect the y-axis. And to find our y-intercept, all we have to do is just take our x-coordinate, which is always 0, because if something has the y-intercept is on this y-axis, any point on this y-axis would of course have an x-coordinate of 0. That's our origin, 0, 0. So it's 0 here, this 0, and our y-coordinate. And our y-coordinate is basically the same as b. So it's 0, b. That's our y-intercept. So now, if we were to take an example like y equals 3x plus 7, our y-intercept would basically be 0, which is our x-coordinate of our origin, and 7, which is our b value. So again, all we have to do is just take our x-coordinate of our origin, which is always 0, and the b value, which in this case is 7, and that will give us our y-coordinate and therefore our y-intercept. So now we can go ahead and graph this y equals 3x plus 7. So I'm not going to draw this to scale in this video. This equation, or this video is just to show you what an equation in the form of y equals mx plus b would look like on a graph, and that means our slope is also not going to be to scale. And in the next video, I'm actually going to show you how to calculate slopes and how to basically graph lines and with your given slope more precisely. But for now, as I said, we're not gonna graph this to scale. So let's go ahead with that. Y equals 3x plus 7. So let's say this is 7 here. Actually, you can move it up a bit. Let's say this here is 0, 7. And let's just graph this. Our line, of course, is going to be here. Y equals 3x plus 7. And that's pretty much it. So I hope you enjoyed today's video and now understand what y equals mx plus b is and how to graph lines in the form of this equation. As I said, in the next video, we're going to go over slopes and how to graph these lines more precisely. So stay tuned for then. And if you have any questions, please leave them in the comment section below. Thank you.